you to draw a graph of what would be on this graph here. Say this is, what, when you're talking about miles per hour, what would we have? Come on, physics people. V and T. This would be a V versus T graph. Just saying. Okay, so we could say it's starting, we'll make it a broken graph, and it's starting at 60, and, you know, we'll use Kyle as an example. He's going, well, he can't be going 60 in the school zone, so let's just, on the perimeter, he's going 60 miles per hour, and then he's thought, oh, I'm just gonna, like, gun it, and then, you know, I'll just, like, I don't know, say, oh, the cops are here. Mind you, 100 miles per hour, you'd be over this. I should make it to kilometers, but anyways. So this would be 100 miles per hour there. That's a little crazy.
And that's not how acceleration works on a graph. Okay.
So, anyways, I want you to see this is continuous, first off, right? Yes? And basically, we know the starting and the ending of a speedy, but we don't really know what's going on in between. But because of the intermediate value theorem, I know he had to have, for sure, I can say he had to have had a speed of, say, 65 in there, or 80. I'm not too sure if he went above 100. All I know for sure with the intermediate value theorem is I know he has speeds between 60 and 100 somewhere in that time. Does that make sense? Yeah. Okay, so now we have this iPhone, and let's say this is the iPhone, I don't know, say 7 because the 8 came out, or the 10 or whatever. So what kind of graph would this be? I'm saying, so this would be the price versus time, yes? Okay, so how does stuff like this work? It started at $5.99?
Yeah. I feel like and then somehow it went down.
So does it actually go it's probably at $5.99 for a while, right? And then they say so then there's the potential that the iPhone 8 is coming out. So then, oh, well, we got to sell a bunch of iPhone 7. So then maybe for some time it's at $3.99, something like that. And then maybe the iPhone 8 comes out, and then they're pretty much giving it away. So I guess the key here is it's not a continuous graph. So there's no way that you could actually tell me, oh, at some point they sold it for $450 or something like that, right? It was like it was $599, and then they dropped the price to $399. There wasn't anything in between. It just all of a sudden one day it went to that price. Does that make sense to you? It's not continuous. I cannot apply the intermediate value theorem, so I can't confidently say at some point the iPhone sold for $450. Something like that, right? Okay, so again, we heard this on the video, but what did it? The key here is f of x is, if f of x is continuous, that's the key here. It has to be a continuous function on the interval a to b, then for every y value d, which is between f of a and f of b, the y values for the x values of a and b, there has to be some x value c in AB. I'm not including AB this time because it's somewhere in between, right? Such that what equals what? F of c equals that d that I'm talking about, right? So a lot of the times on a response question, you just have to say that something is true, and then you say, because of the IVT, or intermediate value theorem. It's not like you necessarily have to state it. However, sometimes in order to state it, you actually have to say that because this is true, this is true. So it is a theorem you should memorize. So again, on that recipe card thing, I would probably write on one side IVT and the other side what it actually is. How many people are getting those cards going? Anybody? Anybody? One person. Two person. I am saying it every time. You should have it in class and then write and then later put it on, right? I think I gave you enough room to draw a graph of this. Let's draw the graph that we kind of saw on the video. So we have some A and some B. And say we have, I don't know, some graph here and it's kind of going to there. I don't want it to be the same level, but I'm going to use different color ink here for the height. So this height, of course, is f of A. And then this height right here is f of B. And so basically what I'm saying here is there's some value, let's say C, between A and B, such that that equals f of C, which equals D, right? Or you could say it the other way. There's some value D between those two values that there's some x value C, right? Okay, so then, I think I must have it below here. One useful application of IVT is finding the x-intercepts, or the zeros. And the reason why this is useful, and we have to prove, is that does everybody understand, in order to find the x-intercepts, and you'll notice this on your graphing calculator, there has to be a sign change that occurs. Like it has to go from, say, a negative y value to a positive y value, or from a positive y value to a negative y value for it to actually cross the x-axis. And that's how your calculator actually solves it, is based on the sign change. So since f of x is continuous on AB, and if f of A equals, I'm going to say some negative values, y values, and f of B equals positive y values, or I could say vice versa, then f of x must have a 0 or an x-intercept between A and B. This is since f of x must hit what on its way from changing from a negative to a positive? It has to go through 0 for this to occur, right? Or it's not continuous. And I left a space there for, I don't think I know why, but for something or other. Okay.
Okay, something.
So we could draw another graph of the same thing. Maybe I'll do that. This time I'm going to have a 4-quadrant thing, and I'm going to have, I don't know, say, so this is my A this time, and this is my B this time. This would be my f of A, and this would be my f of B, and this would be the scenario that it's going from positive y values, because I know it, like in the problem it'll tell me what f of A is. It might be 10, I don't know. And then at B it's, say, -5. I know for sure with the intermediate value theorem there has to be at least 1 0 between them, because it's going from a positive y value to a negative y value. In this case, because I can see visually, there's actually 3. But all I know for certain is there's at least 1 there. Do you see that? Okay. So what I could do is, if I wanted to find all the zeros, I could actually narrow down these choices, right? So say I'm only doing this snapshot. Then I could just go from this A to B and find it, right? I got to find where the sign changes. All right, so first question. Show that this has a solution, meaning a 0 between 0 and 1. Okay. In order for it to have a solution, we are setting y to 0 and solving. Does everybody see that? Okay, so it just says we need to prove that there's some solution between 0 and 1. It doesn't actually say find it. So if I can find f of 0, what is f of 0? Negative 1. What's f of 1? How about 3? So clearly it goes from a negative to a positive. So using the intermediate value theorem, I know there has to be some x-intercept between the two. Does that make sense? Yeah. Okay, so here's a visual of this cubic function. And so the interval 0 and 1 is basically, I'm zooming in between this and this right here. That's 0 and 1 right now. So we're not actually trying to solve what that solution is right there. All I'm trying to do is prove that because it's going from, well, here is my a value, right? A is 0. What's my f value? Well, that was, f of a was negative 1, yes? And here is my b value. And although it's zoomed in quite good, so my b value is 1. The height you can't really see, but f of b is 3. So using the intermediate value theorem, because it's changing sign from a negative 1 to a 3, I've now proved that because we're at some d value of 0, there has to be that c, which is the x or the solution, has to be there. So how would I tie this up? I would say, therefore, by IVT, since, like, basically I'm reiterating the, you know, that's a since, it looks like fence. Let's try that again. Since f of x is continuous. How do I know that f of x is continuous?
Negative number alpha.
Because it's a polynomial function, and all polynomial functions are continuous. We learned this last time, or we knew that from before, or whatever. Since f of x is continuous, and f of 0 equals negative 1, and f of 1 equals 3, there must be a value such that d equals 0, the height equals 0 because of the sign change. Because of sign change. Something to that. Okay?
If we can shorten this.
We probably could. We probably could. Because b slash c is because. Shorthand. It's saying here, show that f of x equals x cubed minus x squared minus 7x minus 4 has at least 3 zeros. So they're telling you, look for 3 zeros, which means I have to look for 3 sign changes. Okay? So, what are we going to start? We're going to start at a. So, f of negative 4. Negative 4 cubed is negative 64. Negative 4 squared is 16, but then it's minus 16. Then negative 7 times negative 4 is plus 28, and then minus 4. And I don't know if I ever showed you this trick before, but, and I know we're all ingrained from bed math, so you go left to right for addition and subtraction. But here's a little kind of trick. If you combine all the negatives together and all the positives together, a lot of the times it's actually way faster than actually trying to go left to right. I don't know. We'll see if it's the case in this case. But anyways, a minus 4 and a minus 16 is a minus 20, and a minus 64 is a minus 84 plus 28. Do you see what I'm saying? It's a lot faster to kind of combine the minuses, combine the positives. So then what is that? Negative 56. Did you use a calculator? Okay, so I'm going to leave some space. I'm going to leave a lot of space since we have a lot of space. F of 4. So what's f of 4? 64 minus 16 minus 28 minus 4. So this time I'm going to actually combine. It's going to be 64. I have a minus 20, so a minus 48. So it's 16. So clearly I found 1 0 has to exist, but the problem is I got to find 3. So this is too large of a gap. So then you might say, well, let's try 0. That's about halfway. It is halfway. F of 0 is what? Minus 4. That's a pretty easy one because it's all zeros except for the minus 4. So clearly I found one between these two, right? So where do you want to go from there?
Let's try -2.
Okay, let's go halfway and go f of -2. So that's -8. Oh shoot, I'm on the wrong side. Thank you. F of -2 is -8 minus 4 plus 14 minus 4. So we have -16 plus 14. So that's a +2. Hey,
No,
look at that.
-2.
Oh, it's a -2. Darn it. Look, it's a negative, a negative, a negative.
-1. -3.
Let's go -1. Somebody sound confident with -1. So -1 is -1 minus 1 plus 7 minus 4. So that's 7 minus 6. Hey, that's a +1.
So that's 2 zeros.
So I found a 0 between these two.
And a 0 between -2.
And a 0 between here and here. So that's 2 zeros.
Between -1.
And hey, I found a 0 between these. I found 3 zeros.
How do you find a 0 between -2 and -56? It's 1 and -2.
Oh, so close. So close.
1 to -2. 1 to
So no.
1
Okay.
to -2.
So 1 and -2, yeah.
1 and -2?
Yeah, well, 1 and -2 would be a 0 there.
Hey, look at that. Yay, I found my 3 zeros. There it is. So using IVT, I found 3 sign changes. So there must be a 0 between what and what? -2 and -1, and -1 and 0, and 0 and 4.
It's +1. Oh, what?